Good morning to all of you. In previous session, we have seen the direct form 1 and direct form 2 realization for realizing IR systems. Right? We have seen one example as well. Right? In today's session, we will be discussing one more example where we will be looking for direct form 1 and direct form 2 realization of given IR system. So for direct form realization, as we have already seen, we can realize any discrete time system by using its difference equation. Okay, so this is nothing but the difference equation. It is the generalized form of the difference equation, so you can use the difference equation for the realization of IR system, or you can use the system function, okay, which is also called as transfer function, right? So from difference equation that is given input output equation, you can obtain the system function or the transfer function. So by using the transfer function or the difference equation, you can realize any given system, right? In case of system function, as we already uh, know that the denominator term should be the first term of denominator should be 1, and the powers of z should be negative before realization of the given discrete time system. And we need only these three uh, building blocks for realization of any IR system or discrete time system, that is adder, constant multiplier, and unitary element. Okay, so all these things we already discussed. So here is an example where we want to obtain the direct form 1 and direct form 2 realizations for a third order IR system. Okay, now in this example, the transfer function is given, right? In previous example that we have discussed in the previous session, there the difference equation was given, right? In terms of y of n and x of n terms were there, right? But here the system function has been given. So we can initially adjust this system function so that we should get 1 here at in this place. Okay, in the denominator the first term should be 1. Okay, and the powers of z should be negative, right? So for making those adjustment, initially we'll write this difference equation, sorry, system function. Okay, so the given system function h of z is equals to this given 0.28 z square plus 0.319 z plus 0.04 whole upon 0.5 z cube plus 0.3 z square plus 0.17 z minus 0.2, right? So to get the value 1 at this place, okay, we will multiply this denominator with uh, 2z to the power minus 3. Okay, so if you are multiplying it with 2z to the power minus 3, so z cube multiplied by z to the power minus 3 will be z to the power 0. Z to the power 0 is 1, and 0.5 multiplied by 2 will be 1, right? So by multiplying the transfer function or system function, numerator and denominator by 2z raised to power minus 3, right? What we'll get? So we'll get h of z is equals to, so if I'm multiplying 2z to the power minus 3 in numerator as well as in denominator, so so multiplying 2z to the power minus 3 and 2z to the power minus 3 in numerator and denominator will not make any changes in the original system function, right? But we are simply adjusting the terms here. Okay, so in numerator, if we are multiplying it with these 2 raised to power 2 into z to the power minus 3, so we'll get 0.28 into 2, it will be 0.56. Z square multiplied by z to the power minus 3 will be z inverse plus 0.319 multiplied by 2 will be 0.638. It will be z to the power minus 2 plus 0.04 multiplied by 2 will be 0.08, and into z to the power minus 3 will be there. Then in denominator as well, we will be multiplying it with 2 raised to 2 into z to the power minus 3. So 0.5 z cube into 2 z to the power minus 3 will be 1 simply, right? Plus 0.3 multiplied by 2 will be 0.6. Z square multiplied by z to the power minus 3 will be z inverse, right? Plus 0.17 multiplied by 2, 0.34. Z into z cube, z to the power minus 3 will be z to the power minus 2. Here it will be 0.4 z to the power minus 3. Okay, so this is the system function which we will be using for the realization of given discrete time system, okay, or IR system, right? So here we'll write or draw the direct form 1 realization structure now. The direct form 1 realization for the given IR system is shown in following figure. Okay, so here before drawing this realization structure, I will rewrite that different system function here, that is h of z. What we have 0.56 z inverse plus 0.638 z to the power minus 2, 0.08 z to the power minus 3. Okay, whole upon 1 plus that 0.6 z inverse, 0.6 z inverse, right, plus 0.34 z to the power minus 2 minus 0.4 z to the power minus 3, right? So this is the function we have. Now we'll try to draw its direct form 1 realization. So in input we are indicating x of n or capital X of z. In output we will indicate it as y of n or capital Y of z. So in input we realize the numerator terms, right? So here first term is simply 0.56 z inverse, so you have to take one delay element, right, that is z inverse, to delay the input by one sample, right? Then you will multiply it with 0.56, right, constant 56. Then it is added. Okay, so we'll need adder here, right? Then similarly the second term z to the power minus 2 is there, so we'll take z inverse again, one more delay element. Okay, then it will be multiplied with 0.638, 0.638. Then again one adder is there, right? It will get added with this result. Again there is another delay element z to the power minus 3, so one more delay element will be taken. Then it will be multiplied with 0.08. Okay, then it will be added here. So here we realize the numerator terms, right? So which corresponds to the input terms, right? That is past inputs or maybe a present input, right? Now we'll try to realize the denominator here. Okay, so for realizing this denominator, we have this output which is fed back into the system. So we'll require Z inverse here, but there is one term, that is first term is 1 here, right? So that should be added, correct? So we'll need adder, so this will be 1, correct? This term is 1. Then 0.6 Z inverse is there, so we'll need delay element. Then the delayed output is multiplied with 0.6, but as it is in denominator, uh, it is a positive term, we had to take it as minus 0.6 as discussed in the previous session, right? Because these terms corresponds to output, and we had taken it from left hand side to right hand side, right? So basically these terms are negative in original. Okay, these coefficients are negative. So then this will be added here, right? Then it will be added with this one. Okay, so next, similarly this 0.34 z to the power minus 2 is there, so we'll need one more delay element in this case, right? So z inverse will be there, then it will be then again multiplied with this 0.34, so it will be minus 0.34, then again it will be added, then again it will be added here. Then similarly this z to the power minus 3, again one more delay element will be there, right? So again we'll get here a minus 0.4 is there, so we'll multiply it with 0.4, then it will be added here, right? Okay, so this is the realization of what? This is the realization of the denominator. Okay, so this is nothing but the figure, that is direct form 1 realization, right? Similarly, we can obtain the direct form 2 realization, where we'll be simply overlapping these two sections so that there will be common delay elements will be there, right? And this output section will be drawn on left hand side, this input section will be drawn on right hand side in direct form 2 realization that was seen in the previous session. So let's try to draw this direct form 2 realization for the given IR system. Okay, so the direct form 2, so the direct form 2 realization of the given IR system is shown in is shown in following figure. Okay, so again I'll rewrite this difference equation here, that h of z is equals to 0.56 z to the power minus 1 plus 0.638 z to the power minus 2 plus 0.08 z to the power minus 3, right? Whole upon 1 plus 0.6 z inverse plus 0.34 z to the power minus 2 minus 0.4 z to the power minus 3. Okay, so let's try to draw this direct form 2 realization. Okay, so as we have to draw the structure on left hand side, right? So here we'll indicate again x of n or capital X of z as input, then we have this adder, right? Then one is there, correct? Then these delay elements will be there, right? As we are realizing this denominator here, so we have this delay element z inverse, then it is getting multiplied with minus 0.6, then it is added here, right? Similarly, second delay element will take, then again it is multiplied with this constant coefficient, that is minus 0.34, right? Here again it will be added, then again third delay element will need, right? So here we'll get it as z to the power minus 3, then again it is multiplied with minus 0.4, means 0.4 we have to use here, right? Then it will be added here. Okay, so this structure we have drawn here, this structure we have drawn at the input side, right? Then these delay elements will be overlapped. Okay, so this will be the common delay elements, same three delay elements will be utilized there, right? So that is the advantage of your direct form 2 realization, that you will need lesser number of delay elements compared to the direct form 1 realization, right? So the remaining structure that you have to draw for the numerator part or the input part. Okay, so here we have this, that 0.56, correct? Here again it will be added here, right? And the output you can indicate as y of n or capital Y of z, right? Similarly here the another coefficient is 0.638, so 0.638 will be there. Again it will be added here, right? Similarly this last coefficient, that is 0.08. Okay, so 0.08 will be there and that will be added here, correct? So this is nothing but what, uh, this figure indicates the direct form 2 realization, okay, of the given IR system, right? So here you can even indicate this output here as well, okay, simply y of n or y of z, or you can indicate it likewise, right? So you can see that in this initial direct form 1 realization we required 6 delay elements, and in this case we required only 3 delay elements. Okay, so this is non-canonical structure because the order of given system was 3. Okay, it was a third order IR system, and here we required 6 delay elements, so it is non-canonical structure, while here we'll require only 3 delay elements, which is same as the order of the given IR system, so therefore it is canonical structure. Okay, so this is how we are obtaining the direct form 1 and direct form 2 realizations for the given IR systems. Okay, so in next session we'll be discussing how to obtain the cascade realization of the given IR system, okay, by using its transfer function or the difference equation, right? So thank you for joining this session.